Hey guys, welcome back to our channel. In this session, we'll be learning how to design and calculate the weight of linkage connector using Catiav5. But first of all, I really want to thank everybody who have supported us by liking the video. Also, we heartily welcome our new subscribers. We post new videos every Saturday and Sunday, and we appreciate your sharing our videos with the friends who are interested in learning design using Catiav5. In the comment section below, you can suggest if you want to learn any particular design using any other software. You can give out comment. Okay, let's get started with the exercise. Here, in this model, you can just check. This is a front view, and this is a top view. It's a linkage connector. So basically, you can see the angle of projection. It is third angle projection. Third angle projection above the front view, it will be a top view. So first let me work on this diameter 50 and 26. Go to part. I'll select the plane which is Y and Z. Now I go for sketch. If you people do not get a sketch, go for insert and you can try for sketch. So you can see grids and all. Now I'll make a circles. So yes. So there is a part called constraint. Give a constraint. Constraint, it's about locking system or giving a relationship or giving a parameter. So without constraint, don't even proceed for creating some other. Right. So let me give 50 and 26, diameter 50, and there you can see it is a 26. So I'll give 26. Now, so let's understand how much it is. Thickness of 44 mm. I'll go make it pad. So here I give 22 and I mirror, it becomes 44 or 44 divided by 2. So either way you can give it. So it is 44 mm now. Now I'll select the front plane. Yes, front plane, it's nothing but YZ plane, and I create. Okay, instead of creating in center, I create it on the edge. So you can see this plane. Yes. Now I'll select the 70 mm. There is a distance of 70 mm. I create a reference element, vertical reference line for 70 mm. Okay. Now I create a circle in center which is nothing but 15 in diameter, 15 diameter and diameter of 28. Diameter. So you can see a tangential line. Now before tangential line I need a projection of a circle. So I'll select this circle. I'll project this. Projection, under operation you can see a tool called project 3D element. I'll project, the color will be in yellow. Now I can make a tangential line. Why I create a projection? Because I need that sketch. Without sketch I cannot give any constraint. Right. So this and this one I give a constraint called tangency. This element and also the projection line. You can see over constraint, it's getting over constraint. Now what I do, I'll delete. So I delete any relation. Properly I give a tangency relation. You can see this. Now I trim the excess lines or a curve. You can see this. If you just check it more clear, you can see excess lines projecting out. This will distract, or it won't make any pad. Right. So you can see a projection line over here, an extended line. I delete the extended line. You can see I delete the extended line. Exit workbench. So now the sketch is clear. So let's make a sketch of certain thickness. So center it is 16 mm. So I'll make a calculation. total it is 44. Right. Now total it is 44 minus of 16 mm, it will be 28. So 28 in both the sides, like divided by 2, 14 mm and 14 mm. Right. Thickness, reverse direction, I'll give 14 mm. So I'll make the same feature by adding up a mirror. I'll select this pad, I'll go to option called mirror. In transformation tool, you have something called mirror definition. Select the mirror definition, select exactly the reference plane. So you can see the mirrored object. Done. Right. Now I go to top plane. I want to make a slot of 20 mm. I use a rectangle tool. I give a constraint. So you can see constraint of 20 mm. I give it symmetrical. It need to be exactly center. So I provide it with respect to center symmetrically. And also there should be a distance. That distance is nothing but 25 mm from the center. So you can see this line need to be respect to the circle axis. So there is a distance between this both, 25. So 25 is the distance. Done. Next. So pocket. So I'll make a pocket in both the direction. Mirror extend and increase the dimension. Need not be any particular, like it can be any particular, not be accurate. So this is how the pocket comes. Okay. So you can see the second half part. Now I want to make the top portion. I will select the sketch in top. I want to give a distance of 60. Make a circular. Select the top plane. I make, see, this is a top plane. I'll select this top plane. Sketch positioning. So here you can see the horizontal and vertical. Just align it properly. Vertical should be always pointing top and horizontal should be always pointing right hand side. I make a circle with a distance of, this circle has a distance of 60 mm. I created with respect of 60 mm. So you can see this. So 60 mm is a distance. Next, what is a diameter? I create a diameter of 26 and also I create a diameter of 26, 12. Okay, exit workbench. Let's give a thickness. Thickness is almost 20 mm. I go for pad, make a thickness. 20 means half of it is 10. Mirror extend, it makes 20. So this is right. Now, so let's understand. I want to give a, you can see from top view, I want to give the rib like a formations. So I'll select the center plane. I go for a sketch. I create a rectangle. In the profile you have rectangle tool. Select the rectangle tool. Let's check what is the thickness actually. It was around 10 mm. Now I make it symmetrical with respect of horizontal. Symmetrical, okay. And here you can see this part. I will extend a little bit. Okay, so first let me understand. I want the projection of this curve. I delete the excess, so I got the projection. So here I'll increase this line a little bit forward. from the center, little forward from the center. I'll know you why. Okay, so go out. Here it is having a thickness, it has a certain thickness, and I'll mirror extend. Okay, so you can see it has a thickness of 44 mm. I'll select it. I'll go to option called in first limit. I'll give it up to plane. I select plane. In second limit, I'll give up to plane. I'll select the second plane. Done. Okay. See, if you do it in this factor, you can see the accuracy will be good. I mean, there won't be any cut marks or a corner little, any edges missing. Okay. So there are n number of methods making this model, but if you try in this method, you will get more accurate. Okay. So let's understand. What I'll do is I want to project this curve. I'll project this curve. First I'll create the profile, then I'll make it pocket. You can see this one. I'll give a relation of tangency. I'll select line, I'll create a vertical line and connect it. So just understand, here you can see there is some small. First let me give a constraint to the end, coincident constraint, say OK. Now extend this line little bit and try to close it with respect to the curve. Yes, like this. So trim the excess. So can you see the curvature is getting trimmed? Why? Because the line hasn't been extended, it's short. So I'll go back. So yes, you can see this line is shorter. I'll extend it. I'll go for a tool called trim, erase. So you can see. So this is a closed body. Now what I'll do is I'll project the center circle. Why? If I do any pocket, it becomes like a hole. And I'll select the whole sketch here and I'll try to mirror it. You have an option called mirror with respect of center plane. Yeah, we got it. Now so make a pocket should be up to last. You say OK. You can see this. So what happens here, you can see these edges, the edge, tangential edge, it won't be exactly center. So that is why I extended little front for making it cut. This shows a model maker. This makes a model more accurate, in fact. And center, you can see a stiffener like a formation, 10 mm thickness. Now I'll go for the center plane. Here I'll make a sketch. The sketch need not be a complete closed body. I'll make it in open condition, just a line. I give a relation between this as a tangency. Then so I need this edge, this surface, exactly the circle edge, and the point of the line I give a coincidence. Right, so this element here, what I will do is I will go out. There is an option in sketch based feature. You can see there is an option over here in sketch based feature. It's called stiffener. Stiffener basically for support we provided. So what is the thickness? It's 10 mm. 10 is the thickness. Say OK, done. So this is how the connecting rod linkage connector looks like. Right. So let's understand. Let's give a weight. Let's understand what's the weight of the object. Okay. So you can see the object is correct. Now here there is an option called apply material. Go for apply material. Apply the material of copper. So under metal you have an option called copper. So in the library, this is a metal library, you have iron and copper. Okay, let me apply a material called copper. So each material varies, each material will showcase a different weight. Change shading with material. Now let me check what is the weight of this component. Under measure you have an option called measure inertia. Select the part body, it will show mass. So this is a weight. So because of like density is 8900, that's the copper density. So weight is 1.188 kg. Thank you. So thank you. Okay, thank you very much guys. Signing off, Team IDI.